Hi class. In this physics problem here, we're given that the mass of block B is much greater than block A, and block A sits on a frictionless surface. Determine the acceleration of the system. So for this type of problem, we're going to have to kind of identify the forces involved in this question here. So let's kind of start with either one. Let's go ahead and start with block A. So if mass of block B is much higher, we can kind of, and block A also sits on a frictionless surface, we can kind of predict the outcome of the system. And the idea is that block A will begin sliding to the right as block B sinks downwards. So if we start with either a mass, either block A or block B, we can start identifying or drawing in free body force vectors, and kind of develop our free body diagrams. I think starting with block B might be easier, but it's really entirely up to you, as you're going to eventually do both anyway. But going forward here, if we look at block B, and it hangs from this cord, certainly there's one force that's present in this. It's going to be the force of gravity. Alright, and I'm going to go ahead and draw that in the downward direction. Let's go ahead and label that the force of gravity. Alright, and the force of gravity is opposed by another force here. This force of the tension of the cord, and of course we'll call that the tension force. Alright, and that's going to be in the upward direction. Alright, and we'll call that tension. Now looking at these two, these forces clearly do not work together, so we're going to have to express a sort of equation between these two forces on block B. And I can go ahead and label it up here. So for block B, we know that there are two forces involved. Force of gravity and tension, and of course they don't work together, so we don't want an addition operation there. And these two forces combine produce some sort of net force. Alright, so with those two forces, they produce some sort of net force, and we're expecting some sort of net force because block B has such a much greater mass. Of course, we can break these expressions down. If we know force of gravity is mg, and then tension is tension, and then that force, based off of Newton's laws, is just ma. Alright. Now the idea here is we know the outcome of the system, so it's something to keep in mind when we're creating these equations. We're expecting the net force to be in the downward direction because we're expecting gravity to be in the downward direction as well, and we're expecting the force of gravity to be stronger. So general kind of helpful thought is you want your net force, the sign of your net force, to agree with a stronger force. And in this case, I have force of gravity be positive and tension be negative. But we know that the force of gravity is going to be the stronger force here, and we want the sign of the force of gravity to match the sign of the net force. Right. You look at this equation and you kind of say, well, there's not much more you can do, and that'd be kind of true. So let's go forward and go to the other block here. All right, and there are a certain number of forces acting on that block. Right. On block A, you can say that there's a force of gravity present, and certainly you can say there's a normal force present. Well, since it kind of sits on the surface, it's not really going to affect the outcome of. It's balanced. The force of gravity is balanced by the normal force here. Oops. Alright, so the force of gravity is balanced by the normal force. Alright, so nothing is going to be affected in the y direction. Alright, but because mass B is so much higher than mass A, it's going to go, it is going to be getting pulled by that cord. And that cord for us is acting in our picture here to the right. Alright, that tension force. There is no friction in this problem, so tension seems to be the only force acting on this on block A here. So we can just kind of label this tension, which probably shouldn't forget that. And tension, that's the only force that exists in our problem, or not in our problem, for block A. Alright, well then, tension is the only force that affects the motion of our block, then tension has to equal to the net force, right? And tension therefore equals MA. Alright, probably should be more consistent with these vectors here, but anyway. So you look at this and you kind of have two equations with all these unknowns, and you want to figure out what the acceleration is determined by. Well, between these two equations that you develop, for one for block B and one for block A, you find that they both have one variable in common, and that is the tension. And that absolutely makes sense because they're both connected by the same cord. Alright, so we have two equations. They share common variables. Alright, and you know what? I actually forgot to do this, but we should probably be specific here in terms of which masses we're talking about. So let me look at A here. This should actually say, you know, to be specific, this should say not just any mass. All right, this should say mass A. All right, mass of block A times the acceleration. And we can probably rewrite this here. Messed up there. Alright, so tension is defined by some sort of net force, and net force is defined by the mass of block A times the acceleration. Alright, and going back to block B, let's go ahead and add that subscript to indicate that we're talking about mass B. So go ahead and erase that. MB. And over here, this is going to be MB as well. Alright. So now we have two equations. Alright, same. Common thing they share is some acceleration. They have the same acceleration, and they share the same tension. So we have two equations, and hopefully this looks somewhat familiar. You have two equations with two unknowns. So what we can do is, well, this looks like a system of equations for us. We can take this, which is what tension is defined by, and plug into there. Alright, and then we can kind of sort of get a new equation here. Alright, mass of block B times G minus tension. Oops, we do know tension already. Tension is just MA, or mass of block A times A. Equals to mass B times A. Alright, and looking at this, if we wanted to find the acceleration of this problem, we can certainly isolate the A variable here. So this is going to be mass B times G equals to and mass BA plus mass A times acceleration. And they have a common term there. We can take something out. Mass B times gravity equals to mass B plus mass A times the acceleration. And looking at this, looks like the acceleration of the system is going to be mass B times gravity divided by mass B plus mass A. And this will give the acceleration to our system. I hope this is helpful, you guys. If you have any questions, please feel free to ask me in the classroom. All right.